This diagram illustrates an 8-bit repairable memory architecture that uses a redundant input-output (I/O) to improve yield by replacing faulty subarrays. The memory is organized into 8 data bits, D0 through D7, each corresponding to a separate subarray with 4 columns, column 0 to column 3, and 3 rows, row 0 to row 2. Each bit has a column multiplexer, column mux, that selects one of the 4 columns for read-write operations. A key feature is the inclusion of a spare subarray connected to bit 7, which serves as a redundant I/O. This redundancy allows the system to bypass a failed subarray by rerouting its data path. When a fault is detected, such as on data bit Q6, the repair mechanism activates. Instead of using the defective bit 6 subarray, the write operation from port data 6 is redirected to the bit 7 subarray via the column muxes. This redirection is enabled by the logic highlighted in blue, which controls the selection of the redundant I/O. The spare subarray effectively replaces the faulty one, ensuring correct data flow. This approach works when faults occur along the same column or within the same memory I/O, making it a robust solution for I/O-level failures. The structure supports 4-to-1 column muxing, meaning each column mux selects one of 4 physical columns per bit. The redundant I/O provides flexibility in repairing multiple column faults within a single I/O, enhancing reliability without requiring complex per-column redundancy. This technique is particularly useful in embedded memories where yield improvement is critical, and it aligns with standard MemoryBIST methodologies for fault tolerance. This figure illustrates an 8-bit repairable memory architecture that uses a redundant column to correct faults in the memory array. The design includes 4 rows, row 0, row 1, row 2, and multiple columns organized into groups of 4, column 0, column 1, column 2, column 3, each corresponding to 1 bit position from data 0 to data 7. Each bit position has a 4-to-1 column multiplexer that selects data from one of the 4 physical columns, or from the redundant column when needed. The redundant column is highlighted in blue and is used to replace any single faulty column across the memory IOS. During write operations, data from port data 7 is directed to the redundant subarray, allowing it to be used for repair. On read operations, the output from column mux 7 goes to Q output 6, while the output from the redundant columns mux goes to Q output 7. This setup enables the system to detect and log defective I/O values and faulty column addresses through built-in repair analysis circuitry. The memory can be repaired if faults occur along the same column, or if exactly one failing column exists within the repair scope. This mechanism ensures reliable operation by replacing a failed column with the redundant one, maintaining data integrity across all memory IOS.
Thanks for watching. This video was made with DocWhisper.com.